Hello friends, welcome to online school. And now today let's talk about indices. And then I've started this by defining what indices or an index refers to. So an index, it is a power raised to a constant or a variable. And then I'm saying that it indicates the number of times a constant or variable is multiplied by itself. Take an example. If at all we have something like 2 to power 4, this is the same as 2 times 2 times 2 and multiplied by 2 again, because now in this case the index is 4, our power here it is 4, so this implies that this number here it is supposed to be multiplied by itself 4 times. And then so this is what we call an index. It could even be x to power 2. So this one here refers to x times x, right, like that. And then so let's talk about the rules of indices. And then so let's begin with this rule. If at all you have any given number m, at all you have any constant or variable m, and then this m is to power p. So we have m to power p, which is our index, p is our index, and then we also have this multiplied by m, which is, so you take note that it is supposed to be the same number. This base here, it is the same number. So if at all you have m to power p multiplied by m to power q, we're taking this like to be our first rule. So this one here, it is the same as m to power p plus q. So it is the same when you just add the indices, provided you have the same base, which is m. And then so let's look at another. Okay, let's first have an example in this. And have here that ig, if at all we have 3 to power 3, then times 3 to power 2. This is the same as 3 to power 3 plus 2. You just add the powers, which is the same as 3 to power 5. And then so let's take about another rule, which is, let's say number 2 here. And then so provided you have a number m to power p, and then this divided by m to power q. So this is the same as m to power p minus q, alright, like that. And then so for example, we can also have an example here. Provided we have 2 to power 2 over 2 to power 1. So this is the same as 2 to power 2 minus 1. And then this is the same as 2 to power 1, which is a 2. Alright, so that has been our second rule. And then so if at all we also have m, let's call it the third rule. So if at all we have a number m or any variable or a constant m, and then this is to power p, but then after being to power p, it can also have the whole of this, can also have another power like q. So and then here we are saying that m to power p, and then in brackets to the power of q, this is the same as m to power pq, which is also equal to m to the power of qp. This is qp, m to the power of qp, like that. And so that's also a rule in indices. And then we can have another property, which is called the zero index. And then so this one states that whenever you have any given number, let me say you have any given number a, or a constant a, and then it is to power 0, this a to power 0, it will be equal to a1, provided that, or given that, our a is not equal to 0. So whenever you have any given number a, and then it has an index of 0, so this will ever and ever be equivalent to a, it will ever be equivalent to a1. And then so before we proceed, let's also talk about something in positive fractional powers. And then so for positive fractional powers, this is where we have like powers of a half, powers of a third. So what does it state? And in this one here, it states that it is positive fractional powers. And so what do we have in this case? So in this case here, we have that if at all, we can call it property 5. If at all we have a square, of any given number. This is the square root of any given number, and then we can take it to be equal to a 2. So this is the same as this very number to a power of a half, and then this is for a square root, and then so it will be the same case if at all you have a cube root of any given number, say 3. So this is also equivalent, to 3 to power a third, like that. And then so we can also have a look at negative indices. And then here you can also have a look at negative indices. So these are like the basics or the rules you need before we begin on this concept of indices, before we begin evaluating and simplifying equations in indices. So we have these as negative indices, and then this one states that for any given number, you can call it 6. For any given number of a constant or a variable, when you have a given constant like n, any number to the power of, or to a power which is a negative index, like that. So this will be the same as the reciprocal of this, and then this index here, it will change a sign to be square. Take an example. If at all we have 2 to power negative 2, this is the same as this inverse here, or the reciprocal, which is going to be 1 out of 2 to power 2 squared, like that. And then so these are the 6 basic properties that we need to know to get started with indices. And after that, the first one we had that m to power p multiplied by any other number. Note that this is the same number, this is the same base here. M to power q, it is the same as m to power p plus q. And then we had m to power p divided by m to power q. So it is supposed to be the same number, like here 2 over 2. And then it is the same as m to power p minus q. Then we have this here, and then we have the zero index. Whenever we get the zero index, and it will give us a 1 provided that our base is not equal to a 0. So these are positive fractional powers, and then these are negative indices. Then the other thing to note is that whenever you have an expression like this, if at all we have an expression like a times b, and then this is to power m, this is the same as a to power m times b to power m. So this one here, it is also going to be important as we go through this topic of indices. And then so after that, let's try out some examples. Using the above rules and basics. So we can have a look at examples, and then we can have the very first one. Here is our very first example. And then assuming we have a question like simplify 3 to power 4 times 3 to power negative 3, right, like that. Or we can begin by this as a, all right, but then we can try out this. And so we have, you note that this base, it is the same as this one here. Both of them, we have a number 3. So this one here, we are going to use a rule which involves multiplication of two same bases, which is the first rule. And then so it says that m to power p times m to power q is equal to m to power p plus q. So this one here, it will be 3 to power 4 plus a negative 3, or I like that. And then this will give us 3 to power, because 4 minus 3, it will be a 1, which is going to give us, a 3. So that was our first example, and hope you've understood how we get that. We are just using the very first rule, and then it's assuming that we also have another number here, or it could be another Roman numeral. So assuming you have 5 to power 6, assuming you have 5 to the power of 6, and then this is divided by 5 to the power of 4, all right, like that. So this is the same as 5 to power 6 minus 4, like that. And then this is going to give us 5 squared, which is a 25. And then so we've used the second rule we had in our first basics. And then so let's also try out the last one before you get to, all right, so let's try out this other one here. Assuming we have that simplify our part 3 as 4 to the power of 6, and then this here it has a bracket, and then it is also to the power of 2 over 3. So this is going to be from the third rule that we stated, and then so this is the same as 4 to the power 6 times 2 over 3, which will give us a 4, and then this 3 can reduce a 6 to a 2, and we shall have 2 times 2 to give us 4 to the power 4, and then this, when simplified, it is equivalent to 256, like that. So and then so those are some of the examples, and before we proceed, I think let's also try out the last one, the very last one, and then I'll give some trial questions concerning this topic of indices. So if at all we also have provided we have something like 27 divided by 64, and then this in brackets to the power of negative 2 over 3. Right, so and then when we get to this, you happen to note that we have a negative index in this case, and then so how do we go about that? Now for this one here, we can first get the reciprocal of what is inside, and then when we get the reciprocal, it will change the whole this sign of the sign of the index to a positive. But then so we know that this is also equivalent to 27 to the power negative 2 over 3, and then this divided by 64 to the power negative 2 over 3. All right, and then so when we reach that step, we can tilt, or we can swap the denominator with the numerator, and then we shall have the signs of the index or the indices change. And then so when we say that, this is going to be 64 to the power 2 over 3 divided by 27 to the power 2 over 3. You take note, hope you see that there is a sign change in this expression here, and then this other expression here. So you're getting a sign change because we have had the denominator shift to the numerator, and then the numerator shifting to the denominator. So this is how it turns to be. And then so after getting that, remember you have 64 to the power of 2 over 3, and then so we can try to express 64 in terms of, I think 64, it has a factor 2, so you can try to express it in terms of 2, and then so this will be, when you try to compute this, it is 2, this is 2 to the power 6, and then this is going to be 2 to the power, no, it's not a 2, it is going to be a 3, this is going to be 3 to the power 3, this is the same as 3 to the power 3, is 3 times 3, 9 times 3 to give us 27, and then even this one here, it is the same, 64 is the same as 2 to the power 64 is the same as 2 to the power 6. So we have this in brackets because this is only for 64, then multiplied by 2 over 3, and then even this 3 cubed multiplied by 2 over 3, and then this is also an index. And then so using this very rule here, this one here for the third part, we can say that this is going to be equal to 2 to the power of 6 times 2 over 3, and then even the denominator, we shall have 3 to the power 3 times 2 over 3, right, like that. And then this 3 will reduce the 6 to get a 2, so we shall remain with 2 to the power 4, and this divided by this 3 will reduce this 3 here to get 3 squared, and then 2 to the power 4, it is going to be a 16 over a 9, like that. And then so can we simplify that further? Oh, so if it can't be simplified further, then we can stop from there. And yeah, so that's it all. That's all what you need to know about indices. And then for positive fractional powers, the same rules also apply. The negative indices, it's the same as taking the reciprocal of that very given number or expression. And then so I think we can have some trial questions. You can try out these questions to check whether the concept is well understood. So assuming we have something like simplify. These are trial questions. Then we have our first number as 4 to the power of negative 3 over 2. And then we have the second one as 81 to the power of 3 over 4. We can have the third one, and have our third expression as and have our third expression as. And in this case, let's say that we are going to be having 27 over 64 to the power of negative 2. Now let's make it positive, to the power of 2 over 3, like that. And then so you can also add, right, you can also add 16 to the power of 3 over 4. Right, and then so that's all about the basics of indices, or the rules of indices. This is how they are applied. And then so in the next video, allow me to talk about how to solve equations with unknown indices. We meet there.